Today our topic is about the output characteristic of the common base transistor, okay, or common base configuration. As we know that common base transistor is mm, okay. Okay, this may be PNP, or if the arrow is mm, if arrow is toward away from the base, this is a base, okay. Uh, This is a base. This is a meter. The arrow represent the meter, and without arrow, that will be our collector. Okay. So if arrow is downward, okay, mean if the arrow is downward toward base, okay. Mm, if the arrow is downward and toward the base, then that will be represent P and P transistor. Okay. But if arrow is uh, upward, then that will be represent NPN transistor. Okay. As we know that in PNP transistor, uh, as we know that in NPN PNP transistor, emitter will be at high voltage and base will be so VE. If I say that uh, I represent okay, uh, then V uh, EB, because base emitter current will be high for PNP, so that will be EP. For PNP, for NPN, that will be yes, for PNP, I must choose the color. For PNP, that will be EB, and for NPN, that will be a BE. That will be a input voltage, and V out will be equal to uh, uh, V because C will be at high, B will be high because it is a reverse bias. Base voltage will be high for output, and collector voltage will be a low for PNP. Okay, so this will be a base collector, but uh, for PNP, this for NPN, this will be a collector will be high because it is a reverse, and base will be low. So that's why the high voltage will become and this is for high voltage will become before. Okay, so that will be so that's why for PNP the output voltage will be VBC, and for uh, NPN, because at NPN collector voltage will be low and base voltage will be high because for reverse bias. So we must write the output voltage equal to VCP. Okay, so there will be two junctions, as we know that I may represent by there will be a two junction. One is JEB. One junction will be this. No, and sorry. So one will be junction will be, I must use the different color. Here that would be I think J. There will be a two junction JEB and JBC. Okay, so now we have to discuss about the output characteristic of the on this transistor. We know that for output, firstly we have to for output characteristic we have to draw the graph between current and output voltage. Before starting it, I write what is the input and what is the output. As we know that if this is an input and if I write this is output, so input current I in will be IE and I out will be IC. Okay, so for both cases for PNP and NPN, I in will be equal to IE and I out will be output current will be IC for both. But voltage for voltage, V out will be equal to V and V out will be V. For PNP, PNP, that will be because meter voltage will be high as compared to base for forward bias. Okay, and meter voltage will be high for forward bias because that will be P will be connected with the this P will be connected with the positive and base will be connected with the negative. Okay, so that's why that will be high. And uh, for P and P, that will be a reverse, but that will be a forward bias. But base voltage will be high, and emitter current will be meter voltage will be a low. But similarly, for the output, that will be a PC, and this will be a B. C. This was a CB. Okay, so this will be the output voltage. So we have to draw the graph between to study the output characteristic. We have to draw the graph. Okay, and the output voltage, as I have already discussed, output voltage will be V out will be V EBR BE, and I will be as I out will be I C. But as we know that as we have already discussed that uh, there is two equations for this. IC, as we know that emitter current will be divided into the IB plus IC. And we know that the base current will be a very, because the width of the base is a very small. So since IB will be a very, very small, IE may be right as approximately IC. Okay, so and the other equation, there was a two equation. One is this, and the second one was uh, IC will be output current will be alpha IE plus current due to the emitter. Okay, and ICB. Oh, this first part is current due current coming from. This is part from the current contribution from a meter current. And this is current contribution. This is mm, this is reverse. This is uh, reverse. reverse reverse bias current, reverse bias current. This is reverse bias current due to due to junction due to reverse uh, bias junction uh, J this JBC, okay, JBC or CB, okay. You may write, may mean that is the junction between base and collector. Okay, so this will be a reverse bias junction. So this will be two parts of the collecting current. One part is coming from the contributed from the input characteristic input current that is coming from the meter, and one part will be the output current. One part is due to what part the other part will be due to the junction base collector junction. That will be a reverse bias in active because yes, that is very important to note. Uh, Both will be and all this is about I must mention that I'm talking about this for active mode, not this is a for active mode, which I have discussed in the previous previous lecture. Okay, so if I draw the graph for active mode, if I consider that, for example, if I say that because this is equal to this, okay, okay, so if I is as we know that IC is equal to alpha I, so if from here, and so if uh, so from IC equal to alpha IE plus ICPO, if IE is equal to 0, then the whole current will be contributed from the then the collecting current, which is output current, that will be equal to alpha that will part will become 0. Okay, and so that will be equal to ICBO, uh, reverse saturated current. Okay, and which is constant, which is as we know that constant and independent from VO, which is a VCB or VO is a VEB, sorry, EB. Yes, what is output? EB, not EB. This is a output voltage is a CB or DC. Okay. So this will be output voltage will be equal to, that was the input voltage emitter base. Okay. So that will be equal to CB or output voltage will be equal to CB or CB or B. sorry, uh, DC or CB. Okay, so output voltage will be why CB? Yeah, uh, sorry, this is again wrong. Actually, I mentioned this. This is I should write BC or CB. Similarly, BC or a CB. Yes, that will be output current voltage. So independent from the so that will be a constant as we know that now. So this will be like this will be a constant like a straight line, and then at the this will be a break. Zener. This will be a break. Uh, and when this will be at this point that will be a transistor, maybe we have to work between these 2 points. Sorry, not we must not limit cross this limit, because after then this transistor will may break. Okay. So this will be actually working because after this the current will be increased instantly, and so we will not consider this part. Okay, so this will be when IB will be this IB will be equal to 0, and and yes, and IC will be equal to IC will be equal to IC common base output. Oh, ICPU common base. Okay, so this will be output current of the common base collector. Okay, okay. So if IB is 0, then collector current will be only depend upon the reverse saturation, reverse current. Okay, that will be a constant, and this will be a constant. Okay, so but when but mhm, but when IB is not equal to 0, then IC will be sorry, IB uh, when IE is not equal to 0. Sorry. Yeah, so if IE not IB, when IE is not equal to 0, then uh, as I have already, that will be alpha IE plus ICPO. Okay, that will be combination of both. Okay, but ICPO is a very small, so that mostly depend upon the and where as I have already explained that alpha is output current, output, and uh, input. Output is as we know that alpha C, and input is I in, and we know that IE, okay, sorry, not in, that will be input current is this. So IC is as we know that IC is equal to alpha. So that will be alpha. If we ignore the uh, reverse saturation current, then I may write, and this is defined as a current gain. Okay, for so this for common base configuration configuration. So as we know that I C is equal to sorry as we know that I have already explained that alpha I E will be divided into I B plus I E, and as we know that because base as and I E is approximately equal to I sorry, and this is divided to IC, okay, and this will be approximately equal to IC because uh, width of base is very width and because the width and doping is very small. I have already explained it in the previous lecture with the IP is very, very small. So we may ignore it. So that's why uh, this will be approximately like this. So from this, alpha become alpha will become approximately equal, not equal. And that will be equal to IE divided by IE, and that will be approximately equal to very equal to 1. Not exactly 1, but that is approximately equal to 1. And it's actually its value will be changed. Actually, its value will be changed from 0.95 to 0.98. It depends upon the width and doping of the. So alpha value will be approximately like this. Okay. So this will be the current gain. Okay. Uh, for common base configuration. So for this case, so if IB is not equal to, so that will be, it mean that will be like, so you may say that uh, IC will be like approximately uh, IE and plus ICBO. Okay, so this is approximately, not, or you may say that exactly this is equal to uh, alpha IE plus IECBO, where alpha is 0.95, 0.95 to 0.98. Okay, so input, so for this, uh, because this is combination, so that will be equal to not like this, then this will be equal to not exactly. This is not a constant because meter is also input current is. This will be a little bit increasing, not exact constant like IB equal to. This is uh, this IB is as this will be a very this will be a constant. Okay, exactly parallel to the output voltage. But this will be not. There will be a little bit. Uh, and the tangent, okay, that will be the tangent will be not zero. The for this tangent will be zero, but for this tangent it will not zero. Okay, so there will be a little bit variation. Okay, there will be a little bit slope. Okay, the slope will be not zero, but this this slope will be zero because that will be exactly constant, and that will be equal to CPU. But there will be some early effect too, but I will explain it later. But for this, this will be this for this that there will be some uh, variation. Okay, the slope will not zero. Okay, so the exactly this this will be for this. Okay, and you may say that you will not consider this part. Okay, must not consider this part. Okay, so in this way, this will be equal to this for this. For IB is greater than, and there will be a different for different I. Mean if this is IB zero, this IB. You may say that here IB is, for example, 10, 5 milliampere. Okay, milliampere is here you may say that IB is equal to 10 milliampere, and in collector current, the so ICB will be equal to, here IC will be equal to IB plus ICBO. Okay, so that will be a different. So IB will be you may say that again. Here here IB may be a 5 milliampere, 10 ampere, and so it may be increasing different values. Okay, but that will be not uh, I think I must draw again. I mean, there will be a little bit slow. There is a slope. Okay, and here you may say that. Okay, here let us let's suppose IB is 5 milliampere. Here IB is 10 milliampere, and here IB is 15 milliampere. So the not uh, IB is not IB. This is IE. Sorry, this is not B. This is about B, not a base current. This is about IE. Okay, sorry. This I must write. This is IE, not B, because input. Okay, but for all these that are not depending the output voltage. Okay, but little bit. This is the one upon the. So this will be your output characteristic, and this will be when the junction GBC, and this graph is about when this region is. Uh, mm, I must write. This is the region. Okay, so this is the region. I must write. This is active region. Active region. Okay. Here, why this is active? Because in this region, both is our common base, base collector current is a uh, reverse wise. But if we reverse it, mean this here in this region where we BC or CB is negative, is that so this is the region where VBC is inverse than the active region. So negative mean inverse, not negative. I say, must say that negative mean inverse. Okay, inverse of active, inverse of active. So because it is a negative, I must I I think if I copied it, understand. Okay. So that okay. So in this region, okay, I now I think it is clear. Uh, so in this region where uh, V out, which is VBC or CB is negative of this is negative mean reverse of active. So because it is will be a reverse of active, so this implies that mm, this implies that in this region VBC junction BC because voltage is negative. So this means junction BC collector base junction. Okay, or collector base junction will be reversed, or you may say from active to become, oh sorry, not active to, uh, or you may say that from forward bias to become reverse bias. So JB will be a uh, no, sorry, this was a reverse bias. So from a reverse bias, it will become a forward bias. Okay, so JCBC become a forward bias. So when this will become a forward bias, then this region, because this is an active region, so this region will be become a, this is a active region, okay, and this will become a, yes, saturated region. Why this is a saturated? Because it become a saturated region. Why this become a saturated region and this will be active region? Because why this is active? Because V out will be forward bias, and V in will be also that will be also already forward bias. In this region, V out will be which is VBC or CB. This will be a reverse bias, and V in is already forward bias. That will be a V EB or a BE. That is already that is a forward bias. Okay, so this will be active, and this the second will be a uh, so this will be a active region because I have already because uh, out is a reverse bias and input is a forward bias. But in this region where output sorry, the junction BC is okay. This I should not write so I'm not should write the jung. I should write, and this is saturation region. It should not be out or VCP. I think uh, I must not output or input current form, but I must write in the junction form. In this region, saturated because uh, J E B is a forward bias, and JBC is also a JBC is also a forward bias. And in this region, because why this is active region? Because here J, this is J, yes, maybe. Here JEB is a forward bias, and JCB is a reverse bias. Okay. So this is the active region. Why this is active region? Because it is commutator emitter base EB or a BE is a forward bias, and CB junction is a reverse bias. So this will be a active region. And so this will be a saturated region. And this mean output current will be behave like a when forward bias, then we know that the output current will behave like a this. Not okay. This is like the forward bias current because the IV diagram of the diode because diode will be behave like a in this junction diode will behave like a forward bias. So the the characteristic curve will be like a forward bias. So this region will like a forward bias because it is a saturated region. So this will be a the for the common emitter common base junction. Okay, characteristic input characteristic of common base junction. What about this region? Okay, because here input current is zero because less than since in this region in all this region IE is less than zero. Okay, so and it mean for all this region. Uh, this is on this. I think I must change the color. I, I must consider so for this region, for all this region where IB is sorry, not IB. I always doing this mistake. IE is less than zero because input current is zero. So input current will be zero. Mean uh, input voltage V in is this implies that V input voltage V in is a negative. Negative mean uh, reverse wise, but V out, which is uh, so this implies that this will be a zero because junction, the junction which is what is the junction that is common base junction. Okay, common EB, meter base junction. EB will be reverse wise, will be reverse, reverse bias. And similarly V out, which is a positive, mean the JCB will also uh, reverse bias as in active region. So, because both are the, and this is also a reverse bias, this is also a reverse bias. So, all this region, which if I start, so this R region will be a, this R region will be, so all this region, all this region will be actually the, this region is a cutoff or switch off region. Mean no current will flow from this region. So transistor will be, we may say that the transistor will be, transistor will behave open or no, or switched off, or has switched off. Mean, mean no current will flow from transistor for IE is less than zero. For IE equal to zero, this will be, so this region will be, so I must say that this region will be, this region will be defined as a cutoff. And what about, yes, you may ask about this region. Yes, what is the this region? Okay. This is inverted, mean this will be not this. Mm. This will be an inverted region. Mean in this region, collector behave like a collector become meter and meter become collector. Why? Because for this region, uh, for this region, yes, JEB will be a, because that will be a, that will be inverted. JEB will become a reverse bias because that is a negative, and J uh, CB become a forward bias, opposite to okay. The reverse will be a here uh, uh, this forward bias will be converted into the, this forward bias will be converted into the reverse bias, and this reverse bias will become a forward bias. So that's why this region will be, sorry, this will become a forward bias. So these are the four regions. Okay, so in this region, the GEB common, sorry, emitter base junction will be a forward bias, and collector base junction will be reverse bias, and this will be defined as active region. But this, in this region, the meter base become a forward bias, but because x-axis will be x-axis is along the BCR output current. Okay, so that will be that here that was a because it is a reverse bias. So when it is inverted, then it will become a active, okay, forward bias. So that will become sorry, yes, that will become a JBC will become a forward bias. Will reverse mean that will become a forward way. That will be I must increase the length of this line so avoid the confusion. Okay. But for this region, when IE is zero, then JAB will be also reverse bias. Uh, will become a reverse bias, which was because it will be inverted in this, that will be a negative, so that will be reverse bias. And why this is inverted? Because why the, because emitter current is zero, that means V in will be a negative, mean that will become a inverted, mean if that is a, because here it is a forward bias, then that will become a reverse bias, and CB will also become a reverse bias. Since both are reverse bias and no current will be flow in this case, so that mean it will be defined as a cutoff region. This is the inverted region because both are inverted, output voltage and uh, uh, collector current is also reverses. So in this region, both is are inverted. So EB will be also reverse bias, and the uh, uh, EB, which was in active region, is a forward bias, become a reverse bias, and CB, which was a reverse bias in active region, become a in a forward bias. So reverse become a forward bias, and forward bias become a reverse bias. So that's why this will be defined as a inverted. So in this region, collector behave like a emitter, and emitter will behave like a collector. Okay, so for today, for this lecture, uh, for this lecture, this will be all about the input characteristic of common base transistor, output characteristic of common base transistor or configurations.